Hello. So today we are going to be looking through the problem BINMIS, which is binary mismatch. So the problem states that we are given a string, a binary string of length n, which means that it'll only have zeros and ones, and we can perform this operation once. So we're supposed to choose two integers, L and R, which are indices of the array or string that we're given, and we have to invert the substring, which is all the numbers from L to R of the string. And when they mean invert, they mean change all the ones to zeros and all the zeros to 1. So we need to find out whether we can make the number of zeros in S equal to the number of ones in S. And we can so we output either yes or no, and if it is yes, if there is a way to make them equal, then we have to output L and R. So we're given the number of test cases, and for each test case we're given the length of the string, which is n, and the string itself, which is s. And for each test case we are outputting yes or no and L and R if it is s. When we look at our constraints, we see that the sum of n over all test cases does not exceed 2 into 10 to the power of 5, which means that O of n will work. So this is our sample input and this is our sample output. So we are asked to convert the string into another string that has an equal number of ones and zeros by selecting a substring and inverting all the numbers. So in the first test case over here we see 0, 1, which isn't that big of a deal because it's already equal. You have 1 0 and 1 1. So what we do is we invert the entire thing, which makes it so that there is 1 1 and 1 0 again. Right? So obviously the answer is yes. When it is, the next test case is 0 1 0, and here we have like an important observation that if n is odd, we won't be able to actually convert it because there is no way that there will be an equal number of ones and zeros because n itself is odd. So you can't have half zeros and half ones. You'll either have 2 zeros and 1 1 or 2 ones and 1 0. So n is odd implies no. Our next test case is 1 0 0 0. Here we see that multiple answers exist. Right? Because we just want to make sure that in the final answer there are 2 ones and 2 zeros. The 2 is n by 2. And to convert this, since there's already 1 1, just converting 1 0 would be enough. And there are 3 zeros. So we could choose any of these and we could make it either 1 1 0 0, 1 0 1 0, or 1 0 0 1. And we also find another important observation that it is the net change that matters, right? So what we can do is select this one as well, but because it turns into a zero, we'll have to collect one more zero than we were initially thinking. So if we take this, for example, then when we invert it, we'll get 0, 1, 1, 0, right? And this has an equal number of ones and zeros. So we see that, okay, it's the net change that matters. Now we want to find out how many ones and how many zeros will have to change. So example, the number of zeros is more than the number of ones. and n is even, because if it was not even we wouldn't have it. So let's say n is 8 and we have 1 0 0 0 1 0 0 0, right? So this has 2 1s and 6 zeros. Our ideal case would have n by 2 1s comma zeros, which is 8 by 2, which is 4 1s and 4 zeros. So we see that we want to convert these 6 zeros into 4 zeros. So our net change is equal to 6 minus 4, which is equal to 2 zeros. We're basically assuming that a 1 and a 0 will cancel out each other, because over here, like we saw, if we select a 0 and a 1, you're not changing the number of zeros and the number of 1s, because all the 1s will become zeros and all the zeros will become 1s. So over here, we see that since the net change is 2 zeros, we can either select a substring of 2 zeros, like this, where it would become 1 1 1 0 1 0 0 0, and you have 4 zeros, 4 1s. Or you could select a 1, right, and 3 zeros. So in this particular one, you have the number of zeros of the substring minus the number of 1s in the substring is equal to 2, right? Net change. Which leads us to a very, very important conclusion, right? We want the number of zeros in the entire string minus the ideal case, right? Which would be to have equal number of 1s and equal number of zeros, which is n by 2 zeros, right? This should be equal to the number of zeros in our substring minus the number of 1s in our substring. Of course, this is assuming that the number of zeros is more than the number of 1s. And in the opposite case, if the number of 1s was more than the number of zeros, it'd be the same thing but reverse, right? Let's just write it here. And of course, if the number of zeros was equal to the number of 1s, we just flip the entire thing, like in this test case over here. So we've already looked at essentially the pseudocode, which would be to find the number of zeros and to find the number of 1s. And if they're after finding out if n is odd, we're finding the number of zeros and the number of 1s. And if they're equal, then we flip the entire thing. If not, we check which one is greater, and then we follow this condition. To follow this condition, what we do is we move from the leftmost, because it's only the net change. So L and R don't actually matter. What matters is the number of 1s and the number of zeros. So what we could do is we could move from the left and move rightwards, right? Until we reach a point where the number of zeros in the substring minus the number of 1s in the substring is equal to the number of zeros in the entire string minus n by 2, which in this case is 6 minus 4, which is, this is 2, and we need to keep on moving this until we get that. So originally you have 1 1 and 0 zeros, and your answer would be minus 1. Then we move here and we'll get 0. And then we move here and you have 2 zeros and 1 1, and you'll have 2 minus 1, which is 1, which is still not what you want. So what you do is you move here and you finally have 3 zeros and 1 1, and which is equal to 2, right? Which is the same as this. So let's look at the actual code. Over here, what we do is we input the number of test cases, and for each test case you input the length of the string and the string itself. You check if it's odd, you see out no, then you come here and you store the number of zeros and the number of ones in the variable 0 and 1. For example, temp basically just converts the character into an int, and you do this and then it is possible. And over here you write if it's equal, you flip the entire thing. If it's more, you do whatever we just said. You go from the left towards the right until you find your required difference, which is equal to the number of zeros minus half the length, or the number of ones minus half the length. And since you started from the beginning, you'll write 1 and the answer, which is your index, which is saved. And that is your answer. I hope you like that solution. Thank you.